Hello there everyone, and welcome to another edition of Starry Skies, the magazine programme that tells you all about what you can see in the night sky in this month of May. I'm Mark Hardacre, but unfortunately our Starry Steve pal, Steve Tonkin, is still recovering from his recent car accident and is still unable to join us this month. We all miss him and send him our best wishes. I do think he'll be back next month. I do hope so. So get well soon, Steve, and we'll see you. In his stead, once again, we get to welcome Kate Earle, the chairman of local Wessex Astronomical Society. Good morning, or good afternoon, or good day,
Yeah.
better still. Kate, how are you?
Hi folks, I'm very well, thank you Mark. Yeah, it's been an interesting month. Did you get out and try and spot the 10 minutes of aurora?
I did, and I did capture it. It was, I think, on my daughter's birthday, the 16th of April, wasn't it? Yeah, there was a flash of pink around my helm. Wasn't particularly bright, nothing like last year's aurora, but I managed to see them, and it looks like we're going to have a good few days of stargazing this first week of May, so get your heads out the door and have a look and see if you can see the stars. So today we're going to be looking at some of the stars and the planets and the other celestial desires?
Well,
Maybe some of those delights that you can see in May. So the full moon, the full moon is not our friend, but the full moon occurs on the 12th of May. So it's this week, the first week of May, or the end of the month, it's going to be the darkest.
yeah, but I have to say though, full moon is great if you want to see the ejector rays coming out of the craters on the moon. That's the best time. So if that's the only clear nights you've got, get out with some binoculars and see those rays coming out of those huge craters, Tycho and Copernicus on the moon, and they stretch for actually hundreds of miles across the moon.
And all caused by impacts.
Yeah.
Although if you talk to Patrick Moore in the day, he did never accept that. Did you know? He always thought that those craters on the moon were volcanic, all of them, and he never gave that up till the day he died.
Yes, I've got a book from the 1980s where he's still absolute stalwart on that. They're volcanoes.
Yep, he never changed until the day he died. But we talked about dark skies, and it's not the best word to use right now, is it, really?
No, it isn't. No, astronomical darkness. Well, you're best on this bit, Mark. I'm going to pass this to you.
Yeah, astronomical darkness is defined as when the sun is 18 degrees below the horizon. That's when it's officially, for astronomers, dark. And from the 27th of this month, 27th of May, until the end of August, there's no official astronomical darkness here in the south of England. And if you're from up north like me, it's even worse. Up in Keighley, West Yorkshire, where I come from, there's no astronomical darkness at all in May until early September, because they're that much further north up there, of course. And, of course, with the clocks now on summertime, the darkest period of the night is actually 1 a.m. and no longer midnight. So, what about those 5 planets then? They've all gone.
Well, they have, yes. But no astronomical darkness is no excuse not to get out, because we've still got Jupiter over in the west. It's quite low, but it's still very, very bright, so you can't miss it. It's kind of on its own out there at the moment. So grab a pair of binoculars if you can and try and hunt down some of the Galilean moons that you can see.
Absolutely. And it's you probably see it for an hour or two around 10:30, 11 o'clock, but then it sets, and following close behind it is the planet Mars, which is receding from us and growing dimmer every day in the constellation of Cancer.
Yeah, it's not looking too hot now, really, is it? We've got to wait till 2027 till we get Mars looking good in our evening skies again.
Yeah.
So
It's about every 2 years we see Mars, isn't it? Every 2 years, and we see it for about 6 months, and then it disappears again.
We're on the inner racetrack circuit, aren't we? Really, so we speed round the sun much faster than Mars does, almost double the time, and so we lose it for quite a long time, and then we catch up with it again.
And all these objects you can find, of course, on our monthly sky charts, which are on the Forest FM website and Facebook page, as well as our Astronomical Society pages as well. As to the 2 innermost planets, so Mars, as he's just saying, Kate, is on the outside of us. Mercury and Venus are on the inside of us. What about those 2?
Well, they're visible if you're an early morning riser. so I can't say I'm going to see Venus for a few months. But if you do get up for a toilet break in the night, have a look out of any eastern window, and you may well see Venus shining. It's kind of at its brightest at the moment.
Yep.
And if you are inclined to get out a telescope, you will see that it looks like a tiny, tiny crescent at the moment as well. Very beautiful, but really not best sort of seeing. And Mercury actually isn't around this month at all.
These two inner planets are always close to the sun, and neither of them particularly good at the moment. Not like Venus was in the last few months when it was in the western sky in the evening. Same applies to Saturn. Yeah. Unfortunately, Saturn is still very near to the sun. It was in the evening sky all the way through January, then disappeared behind the sun. And it's not really emerged. It'll be along in June, July, but it's not going to be very good until probably August or September. So then we move on to our constellation of the month. Constellation of the month this month is Cepheus. And who was he? He was the King of Ethiopia.
He was, yeah, married to the vain Queen Cassiopeia, who's up in the sky on her throne, placed upside down as a punishment for being so vain. But yes, he was her king, so to speak. And but we'll more on that later.
Indeed, you'll find him low in the northern sky this month, and that is where we'll start. It's a good time. So let's just first of all talk a little bit about this sunset stuff. So in mid-May, sunset is around 9:15 in the evening here in the Dorset, Hampshire listening area. The astronomical twilight doesn't start until midnight, would you believe?
It's really late.
midnight. Yeah. In the middle, there's a thing called nautical twilight, which I always find really quite amazing, especially if you're on a cruise. Nautical twilight is defined as when the sky and the sea are the same colour. You can't distinguish them.
Can't tell the difference. Yeah.
And that takes place at 22:25, so 10:30 in the evening. And then the sun goes round and starts coming up again, and astronomical twilight starts again at 02:22. So we only have 2.5 hours of darkness in May, so make the best of it, because by the end of May, that's your lot. You won't get any at all.
But summer is on its way, though, as you know, this weather this week is going to be absolutely stunning.
Yeah, this first week of May, it looks like it's going to be barbecue weather again.
Barbecue weather in the day, and then stargazing at night.
Absolutely, absolutely. So let's turn this time to the north first. We usually start these starry skies looking to the west where the sun has just gone down. But let's turn to the north first this time, because almost overhead, as the sky darkens, you'll see that famous signpost in the sky, the plough. And we often mention this asterism in the sky because it's so many people can recognise it. It's easy to find, isn't it, Kate?
Yeah, it's very prevalent in a lot of cultures around the world. Yeah.
We see it as a bear. The Greeks saw it as the Great Bear, but other cultures saw it as other animals or objects, right? Yeah,
so you see it as a giant sort of caribou. And in fact, other cultures in North America see the four stars in the square as the bear, and then the stars in the tail as the three hunters kind of carrying the fire and the pot to cook the bear in.
Oh, so, right.
Yeah.
I didn't know that one.
Yeah.
You learn something every day on this programme, you really do. And of course, most people know that if you follow the pointers, so that in that bowl you're just talking about, the front two stars are called the pointers. And if you follow them, in this case, actually down, you'll find the pole star, which was used and has been used by mariners for centuries to show them the way home. And why is that?
Because
the Polaris hangs over the pole.
The pole, yes. Mark, call me out there, folks. Yes, if you were to go to the North Pole and look directly above your head, the North Star would be right there. But of course, and it lines up with the Earth's axis, so it doesn't move, even though the Earth is rotating. But of course, here in the UK, we're not at the North Pole, maybe quite fortunately. Yep. We are down, and how many degrees are we down?
About 51.
51.
Roughly 51
so
degrees.
That's how high Polaris appears in the sky to us here, but it still doesn't move. So all the stars, appear to go around it, but of course it's not the stars moving; it's the Earth that's turning.
Right. And if you're at the equator, which I was fairly recently on a trip, Polaris is actually on the horizon. Because as you're looking north from the equator, you're looking towards the North Pole, and there's Polaris right on the equator. So Polaris shows us not only which direction north is, but its altitude in the sky tells you whereabouts you are on the Earth from your latitude point of view. Yeah. As you say, we're about 51 degrees here in Dorset and Hampshire. Incredibly
useful star, but it wasn't always the North Star. We have a kind of a number of stars that end up being the North Star over a period of about sort of 28,000 years, because the Earth's axis wobbles a little bit in something called precession. So at the moment, the North Star is our North Star, but for the Egyptians, the North Star was Thuban, a star in Draco. So it does change over time. So
yeah, not during a human lifetime. No. Our human lifetimes, we will still see it as Polaris as the pole star. But as you say, over 10, 15,000 years, it does change. So if we continue that line from the pointers through Polaris a little way, you'll come to that rather inconspicuous constellation of Cepheus, the king. I always think of Cepheus I think it looks like a child's drawing of a house. So it's low on the northern horizon, below Polaris. I think of it as a child's drawing of a house, boxy sides and a pointed roof. If you have a look at the Constellation of the Month map that we've placed on the Forest FM Facebook page, you'll see what I mean. It looks just like a little... It's quite faint, though.
Yeah, really. It's quite faint. I'm surprised it's even really a constellation, because the Greeks and the Romans as well tended to ignore sort of fainter areas in the sky. They were like deserts to them. That's kind of pretty much what they called them. Yeah. But Cepheus, as I call it...
What? she's had that traditional... education.
I did do a bit of Latin at school, yeah, and I think probably it's a hard k sound, but a lot of people say Cepheus. So Cepheus or Cepheus.
She's
as
right.
As long as you love your mother, as my father would have said.
It is definitely Cepheus. I also did Latin at school, as did Steve Tonkin. So just to mention for Steve, he would also say not Cetus the whale. He would say Cetus, which, as you say, hard C is what we need here. Anyway, in mythology, King Cepheus was the hen-pecked husband of Queen Cassiopeia and father of beautiful Andromeda. And both of those constellations are in the sky nearby. We mentioned Cassiopeia already, which is a brilliant W shape. Everybody can find that as well, right next to Cepheus. And then once you've found Cassiopeia, finding dim Cepheus is fairly easy then. It's a dim constellation of the month, because it's got some interesting objects in it, which we'll talk about now. In fact, it's home to one of the most interesting and important variable stars in the sky, a star that's called Delta Cephei.
You like your variable stars, don't you?
Yes, I'm a member of the American Association of Variable Star Observers, and I send my observations off to them periodically. There's something really magical about taking a pair of binoculars and watching a star as it grows bright and bright over a few months and then slowly fades away and then comes back bright again in a way that is often irregular. There's no rhyme nor reason to why it does it. Some of them are very regular, as you know. Delta Cephei is extremely regular. It's like a little clock, and we'll come to that in a second. To find it, go to the bottom of the house, have a look at the map again, bottom of the Cepheus little child's house, and you'll see a little triangle of 3 stars. Of course, triangles are 3, at the lower left of the constellation, and Delta is at the tip of that. It's not particularly bright. You don't need binoculars to see it, but it's not particularly bright. But it is the prototype of a class of variable stars we call Cepheids. So, it's a massive yellow supergiant star about 1,000 light years from Earth, and it was discovered to be a variable. That's one that just changes its brightness steadily over time. Back in 1784, by a guy called John Goodrick. He noticed that one day it was bright and then the next day it wasn't, and figured out that it changes its brightness in a period of 5 days and 9 hours. How about that?
Yeah. And he was actually a very brilliant observer, actually. It's quite a sad story, really, because he went deaf in childhood because of an illness. But he was a great observer of variable stars. There's another nearby variable star called Algol, which is known as the demon star because it changes its brightness so often.
Yeah.
And he put forward ideas about why these stars change in their brightness. But he died at the age of 21 from pneumonia.
Yeah.
Yeah, really, really great loss, actually, to the astronomical community.
And British as well, or English, should I say. Yeah. So delta changes its brightness from, we call it magnitude 3.5 to magnitude 4.4. Very, very bright stars are 0 magnitude, and the faintest stars we can see with the naked eye are 6th magnitude, with binoculars down to 10th magnitude, with the space telescope down to about 30. So this is just a way that astronomers calculate or observe stars or their brightness.
The higher the number, basically, the dimmer the star, which is sort of opposite to how our brains work.
Yeah, that's right. So delta does this brightness changing by pulsating. It actually does grow bigger and dimmer as it grows, and then 5 days later it starts and shrinks in size, and it slightly changes colour. Do you know that? It very slightly changes colour from normally it's yellow. It's a super yellow supergiant, and it goes slightly redder as it expands. And it turns out there's hundreds of these Cepheid variables in the sky, and this is the important thing, that period of variability, how many days or weeks or months it takes to go from bright to dim to bright again, that is linked directly to its luminosity. That means the more luminous the star, the longer the period. So that means, you could use it as a standard candle, right? That means you should be able to find Cepheid variables in the sky. If it's got a long period, you know that it must be a very, very luminous star. If it's not luminous, if it's not bright, it must be a long way away.
Very far away.
And that's how we managed to figure out the distance to galaxies. And that was, you've heard of Edwin Hubble.
Mr. Hubble, yeah, the space telescope
guy.
Yep.
He was the guy that discovered the Cepheid variables in the Andromeda Nebula, as it used to be called. So the Andromeda Nebula was thought to be a patch of dust and gas within our own Milky Way galaxy. Turns out that it's not that at all. He found some Cepheid variables and was astonished to discover that they were miles and miles and millions of miles and light years away, and that Andromeda was not a nebula within our galaxy, but was in fact an immense galaxy just like ours. In fact, 2.5 million light years away.
Amazing.
So, yeah, since then, Cepheids have been used to map our galaxy as well as calculate the distance to others. And guess what? Do you know what Polaris is?
I guess it's a Cepheid variable.
Did you know that?
I did know it was a variable star. I didn't know it was a Cepheid variable, though. Yes.
The brightness change is barely perceptible.
Right.
It's a very, very tiny amount, barely detectable by amateurs. But it is a Cepheid
There we
variable.
are. It's also a triple star.
It is.
At its minimum, I think. They think there may be some more sort of hiding. And you can pick up one of the other sort of sister stars if you've got a big enough telescope. I've never seen it, actually. Have you seen?
Yeah.
It's,
you'd need the 6-inch telescope to see it, I think. But,
not a binocular object.
But, it's not binoculars. That's true.
We're just going to interrupt Mark here. So he doesn't know I'm going to say this, but this is another one of my little things. So when we talk about constellations, we talk about sort of objects within them. So we're talking about particular stars in them at the moment, but also within the boundaries of a constellation, you can have other galaxies. Any object within a constellation is defined being within that constellation, but it can be very, very far away. And actually within Cepheus, there is
She's done it again.
there's a huge galaxy, but what's more interesting about it is that it's got a supermassive black hole at its center. So all galaxies, we think, have supermassive black holes. They're areas where it's huge amounts of gravity. It's so dense that sort of nothing, even light, can't escape. And we're not really sure how the supermassive black holes at the centre of galaxies form. We think that they maybe lots of little black holes join up over time, and then eventually that hole gets much bigger and it can actually gobble up material in the middle of the galaxy and feed on that for many years. And the one at the centre of the Milky Way weighs about 4 million times the mass of our sun. Now, sometimes in astronomy, we're dealing with such big numbers, it is hard to visualise things. So let's think about that our sun is represented by 1 second.
Aha.
Okay. And then, a million seconds is about 12 days. So in that scale, our supermassive black hole in the Milky Way would be represented by about 48 days.
Okay. This is
4 million seconds.
Yep.
This supermassive black hole in this galaxy in Cepheus weighs as much as 40 billion suns.
What?
So if you turn 40 billions into seconds, you end up at 1,300 years.
My goodness.
So it's just another way of kind of seeing sense of scales in the universe. So huge supermassive black hole. Nowhere near us, nothing to worry about.
Oh, yeah, exactly. And that's a really good way to imagine, excuse me, large numbers. All astronomers, we have the same problem. How far is it to Sirius? Well, it's so many billion. The human mind can't cope with it.
No, it can't.
So that's a good way to imagine how big that black hole in the middle of a galaxy would be. Talking of huge, there's another huge star that you can find in Cepheus. And again, that's marked on our map with the Greek letter mu. Back in the day when we were starting to catalogue the stars, a guy called Bayer started to use the Greek letters, the alphabet, to name the stars in the sky. Each constellation had an alpha, that was its brightest star, then beta, gamma, and so forth, all the way right down to omega. So I think that's 26.
24.
24, thank you. 24 stars you could have named. And this particular one I'm talking about is called Mu Cephei. It's a huge red supergiant star, and it's so big that if you put it in our solar system, it would billow out and its atmosphere would stretch all the way past Mercury, past us, swallowing us up, Mars, all the way out to Jupiter. Massive, also quite cool. It's red. It's red hot. It's not white hot or yellow hot. It's red hot. And very easy to see in the sky with a pair of binoculars. You can find it with the naked eye too. It's a bit dim, but if you have a look with binoculars, you'll see it's glowing like a piece of coal, like an ember from a fire. So you can see Mu with the naked eye. The German English astronomer William Herschel called it the Garnet Star. Have you ever seen the Garnet Star?
I have. It's actually one of my favourite kind of stars because I believe it's one of the carbon stars, which, because in astronomy we often don't have a lot of colour. I mean, there are subtle hints of blues and in a hot star and reds in a cooler star, but these things really do show an amazing redness, and they're called carbon stars because, of course, stars, when they're coming to the ends of their life, they've burnt their hydrogen and turned it into helium, and then the helium gets hot enough to turn into carbon and oxygen, which is why there's so much of it in the universe. And it's no real surprise that our bodies and a lot of the earth are made up of carbon and oxygen because there's so much of it.
Yep.
And in these particular stars there's lots of circulation going on, so that carbon gets dredged up, and it basically is like soot in the atmosphere of the star, and that soot scatters any blue or green light that there is coming from the star, so it just accentuates that redness.
Right. And that makes Mu Cephei not only a carbon star, a red carbon star, but it's a variable star too, because this puffing out of the soot from the inside of the star to the outside dims the star, and it does it in an irregular manner. So it billows up, becomes darker, and then recovers and gets brighter again over a period of several hundred days in the case of Mu Cephei. Very nice to find with binoculars.
Yes,
it's nice.
great
Have
objects.
a look for it.
Yeah.
And while you've got your binoculars out, see if you can find a pretty little star cluster just to the north. Have a look at the map again. Up by the very tip of the roof of Cepheus, extended up towards Polaris, and there you'll see NGC 188. NGC is the new general catalogue. It's a list of all the fuzzy objects in the sky, this is 188.
I was going to say that wasn't Patrick Moore, that's the Caldwell catalogue.
No, this is the NGC was formed out of Messier's original list of 110, William Herschel's lists of a couple of thousand, his son John's list of another couple of thousand, and even Caroline Herschel,
the sister.
So there's about 7,800 objects in the NGC catalogue, and we still use that as astronomers for finding our way around the sky. So that little cluster is very close to the pole star, and you'll see it in binoculars. It's a little patch of stars, probably several hundred. They were all formed about the same time, and they're all held looser together in the sky. So, talking of open star clusters, let's turn our attention back to the west, where you can find Mars. So, it isn't as bright as it used to be a couple of months ago, but you can still find Mars. And fascinatingly, this month, it's moved from the constellation of Gemini into Cancer on May the 4th.
Star Wars Day. May the Force be with you. Yep.
And for a day or so on either side of it, Mars will pass very close to one of the nicest star clusters in the sky. I'm going to have to cough. Excuse me, folks. Sorry about that. That's been coming on for a while. So Mars is going to pass very close to one of the nicest star clusters, and that's called M, or Messier 44. It's a wonderful star cluster. So when's May the 4th, I think, is Sunday, isn't it? Which is the day that this show will be broadcast or rebroadcast.
That's correct.
So have a look. If the sky is still clear, look for Mars with the naked eye, and then get your binoculars out, and right next to it you'll find this star cluster made up of dozens and dozens of stars, all very bright. The day before that, Saturday the 3rd, the crescent moon will be there as well. That will make it even easier to find. So if it's clear on Saturday the 3rd, if you listen to this on Sunday, hard luck.
Yes.
You've missed it.
Where were you?
Where were you? Yeah, but Saturday the 3rd of May, have a look. You'll see the crescent moon, you'll see Mars, and this very pretty picture of M44 or Praesepe next to it. So, great.
Yep, and you can see that with the naked eye, actually, but you need to go somewhere dark. When I was at Hengistbury Head trying to spot the aurora and failing, you could see it, in darker skies. But it's also called the Beehive cluster because it looks like a little swarm of bees, especially in binoculars.
Yep, it does indeed. So, okay, let's turn our view from facing west now. Let's turn a little bit to our left. Now we're looking south, and you're looking directly during May at the zodiac constellation of Virgo.
It's the one we covered last month.
We did cover Virgo. It was a constellation last month, and its brightest star, Spica. And of course, we reminded you how to find it last month. Can you remember, Kate, how to find it?
Yes, this time. Yes, you arc round the handle of the plough. So you arc to Arcturus, and then you speed on to Spica, or spike down to Spica.
That's it.
Yeah, it's very clear there in the south at the moment, Spica.
Yep.
Yeah, very obvious bluish-whitish star.
Yeah, it's in an area of the sky where there are very few brighter stars. So if you look south, about halfway up the sky, you can't really miss Spica. But that's the official way to find it, is from the plough, arc down to Arcturus, the brilliant orange star in the constellation of Boötes, and then spike on or speed on down to Spica. So let's keep looking there, let's keep on spiking down past Spiker, look down then towards the southern horizon, and below Virgo you'll find a pretty little group of 4 bright stars, and I love this constellation. It's the constellation of Corvus the Crow. You seen Corvus? Yeah.
Yes, yeah, as I said, one of my favourites as well. Beautiful little square, well, quadrangle really, is it's not quite a square. And as I brought up in last month's Starry Skies podcast, that was known as Spiker's Spanker to the ancient mariners because it looks like a sail, which of course that's what a spanker is.
That's it, and it's due south, so around midnight, around the time it gets dark, you can see it to the south there. So it's a lovely little constellation. And
then just heading up in the east, we've got the summer triangle stars rising, which will denote the start of summer coming.
Yep. So again, we turn further around to our left, and we'll see there rising strongly in the east, Vega, brilliant blue Vega, and Deneb in the constellation of Cygnus. And in a few weeks' time, in June, July, you'll see these stars dominating the eastern and southern sky. This is the summer triangle, and we'll talk more about that next month indeed, and subsequent months, I'm sure. So all these constellations can be seen in our monthly sky chart, which we have on our Forest FM Facebook page, as well as online at our Fordingbridge Astronomers and Wessex Astronomical Society pages. And if you're interested in finding out more about astronomy, then the best thing you can do really is contact your local astronomy club. Why? Because there's no point going out there and buying gear and then being disappointed. Come to an astronomy club. We will show you what's available. We've all got ranging from nothing, ranging from just our eyes, up through binoculars, up to the biggest telescopes. Depends on your budget and your interest, and you can use these at astronomical clubs and decide later what you're going to buy. So who are we? Well, Fordingbridge Astronomers meets every third Wednesday of the month at the Elm Tree in Hightown, and we really do welcome anybody along. We're a social group too. We have lots of fun.
Lots of beer. You're missing that bit out.
Well, I'm not. Am I allowed to talk about
fun and beer are equated.
Fun and beer. We have beer. That's why we meet in a pub. Wessex.
Wessex Astronomical Society. That I'm the chair of.
Which you're the chair.
Yeah. Meet at the Allendale Centre in Wimborne on the first Tuesday of the month. So our meeting's actually coming up this Tuesday. We'll be welcoming Brad Gibson, who'll be talking all about how the universe will end.
Ooh. Not this week though. Hopefully. I mean, the universe ending.
Well, you never know. Depends if you live in America or not.
Oh, no, don't start that. And then finally, Cranbourne Chase Astronomy Club meets on the second Wednesday of the month up at the Grosvenor Hotel in the centre of Shaftesbury. A great place to go. So there's 3 astronomical societies just around here. All very active, I have to say. We're all very busy. Astronomy is such a popular hobby, and the people love to get out under a dark sky, which we're fortunate to be close to here. The New Forest, the Cranbourne Chase National Landmark are all great places to view the stars. We all these clubs welcome new members, and you don't need any kit at all. Don't even need eyes, as you pointed out last month,
you don't.
Kate.
It's just, as you say, thirst for knowledge and interest in just the world around you, really.
Yeah, indeed. So thanks for listening today. Do have a look, as I said, have a look for Mars and the Moon on Saturday if you can. And let's hope it's nice and clear for us for the rest of the week. We'll see you next month. So it's goodbye from me, Mark Hardacre.
And it's goodbye from me, Kate Earle.
And most importantly, clear skies.